So subtracting your x squareds go away. 0 minus 3 would be negative 3x, and then minus 5 comes down. And then what times x would give me negative 3x? Negative 3. Yes, sir.
Wouldn't negative x times negative 3 constant?
It is.
So
We're subtracting. Negative 3 times negative, or times x would be negative 3x. Negative 3 times negative 3 is 9. Parentheses, subtract. The x's go away. Negative 5 minus 9 would be negative 14. This is our remainder. And remember in Algebra 2, when we wrote that remainder, we did plus negative 14 over x minus 3. And that was our quotient with the remainder there. That's how we wrote our remainders. Remainder over what you divided by. So long division. Don't use that a ton when you're solving polynomials, but it does come up later on when you do rationals equations. So just reviewing that now because it's directly related to the next thing, which is synthetic division. Let's do synthetic division with the exact same problem. X cubed minus 4x squared minus 5 divided by x minus 3. The difference in synthetic division and long division is one thing is that you don't have all the x's involved when you're doing synthetic division. Another thing is that you can only do synthetic division by a linear divisor. You can't divide by a quadratic or anything higher than power degree 1. So if you're going to use synthetic division, your divisor has to be linear or degree 1 to do synthetic division. So that's handy because when we're trying to factor a higher degree polynomial, we want to get those factors like we were building the polynomials in the first section. You want to get those x-intercepts, and we can represent those using those linear factors out of that. So setting up, one thing I always call it the shelf number, but your divisor number. You want to take what you're dividing by, set it equal to 0, and solve. We know that that just changes the sign, makes it a positive 3 that we're using as the number that goes on the shelf. And then in the top row on synthetic division, it's going to be your coefficients from your dividend, what you're dividing into. So 1, negative 4, 0, negative 5. Again, you've got to have a representative from your highest power of x, x cubed, x squared, plain x, and then x to the 0 power is out of that. So that's got to have a representative for that. So if there's not one there, put a 0 in its place. Now, synthetic division, if you remember how to do that, you drop the first number down. So 1 just drops straight down. And then you multiply. 1 times 3, 3. And then you add. Negative 4 plus 3, negative 1. And then multiply. Negative 1 times 3. And that's negative 3. Add. Multiply. Negative 3 times 3. Negative 9, and then we get negative 14 over there. That last place, that's your remainder, just like it was in the long division. And when you do synthetic division, it always takes your degree down by 1. So we started with x cubed. Now the quotient starts with x squared. It always takes your degree down by 1. So that's going to be x squared minus x minus 3 plus negative 14 over x minus 3. So it gets you the same quotient, same remainder as it does with long division. But synthetic division, a little quicker, a little cleaner, not as much distributive property and all that stuff to do out of that. So, but it only can happen if you're using a linear divisor. Okay, only linear divisors. All right. Now, what we utilize when we're trying to solve polynomials is the factor and remainder theorem. It says that x minus c, or c is a number, is a factor of a polynomial if and only if f of c is equal to 0. What that tells us is that the remainder is 0. Synthetic division, you might hear some people call it synthetic substitution. It's exactly the same thing. Synthetic division, synthetic substitution are the same math. It's not different, depending on who you study under, what they call it. So synthetic substitution, synthetic division is the same thing. So what that tells us is that if we divide by this x minus some number or x plus some number, if we divide by that and we get a remainder of 0, then that means that's a factor of the original polynomial. Okay, then that helps us break down that polynomial and get it to something we can work with more. Like I said, stuff you've done in Algebra 2, so shouldn't be anything crazy difficult here. Is x minus 1 a factor of f of x equals 2x cubed minus x squared plus 2x minus 3. Okay. Now, the way to determine that would be to do division by this factor, or maybe it's not a factor, I don't know, it depends, into this polynomial. Can we use synthetic division to do that division? Yes, because this is what kind of factor? Linear. It has power degree 1, so that means we can do that with synthetic division, which is much easier than long division. 2, -1, 2, -3. What goes on the shelf out here? +1. And then run through that. So 2, and get a remainder of 0. So is that a factor of that polynomial? Yes. And the factor, what happens here is we get the x minus 1 as a factor and then get this quadratic left over. And then, we would hope that maybe this factors a little further. Maybe it does, maybe it doesn't. That helps us break down that polynomial into something smaller that we can probably work with a little bit more. Okay. The next thing that we talked about in Algebra 2 were possible rational zeros. Okay, so we're going to find all the possible rational zeros and factor the polynomial. Okay. So here's our polynomial. 2x cubed plus 11x squared minus 7x minus 6. And in Algebra 2, we talked about that possible rational zeros theorem where you had P over Q. Okay, that triggers a little memory there. The P over Q list. And the P over Q list took all the factors of the constant on the end over the factors of the leading coefficient. So we're looking at factors of 6 over factors of 2 for this problem. So the factors of 6 are 1, 2, 3, and 6. The factors of 2 are plus or minus 1 and 2. So the P over Q list is then plus or minus all these numbers that I'm going to put in that bracket. Well, if I divide 1 by 1, I get 1, 2 by 1, 3 by 1, 6 by 1. I just get those integers back. 1, 2, 3, 6. Then I divide each of these factors on the top by the next factor on the bottom. 1 over 2, 1/2. I don't have that one written yet, so I'm going to write it down. 2 divided by 2 is 1. I've already got 1 written, so I don't write it again. 3 divided by 2, 3 over 2. I don't have that one written yet, so I'll write it down. 6 divided by 2, 3. I've already got it, so I don't write it again. And so these are the possible rational zeros. So I've narrowed it down from all the numbers in the world down to 1, 2, 3, 4, 5, 6, 12 possible numbers that could be rational zeros. Doesn't mean that all of those are zeros, just means that those, if there's a rational zero to this polynomial, it's going to be one of those 12 numbers. Okay. Now, when I was in high school, we didn't have the nice graphing calculators that you guys have now. We had to actually just guess and try. And that stunk if you didn't make a good first guess out of that. So, but you guys have a graphing calculator, so we can shorten up the process a little bit here, because we know if we're trying to find zeros of a polynomial, what are we looking for? X-intercepts. Those are the same thing. So X-intercepts and zeros are the same thing. So if we can graph this polynomial, we can look at where it's crossing the X-axis, and that's going to help us get started with our synthetic division. So that's what we're going to do, is graph that polynomial. So pull out your graphing calculator there, start that thing up, and let's graph that polynomial and see where it crosses the X-axis. Y equals, pull that one out. We have 2x to the third plus 11x squared minus 7x minus 6. And hit graph. All right, so I see it crossing the x-axis in 3 places. It's got degree 3, so that kind of makes sense that it could have up to 3 places that crosses the x-axis. So what's this one look like? -6. That's right on that. So we know that that's probably true. I can test that with my graphic calculator by hitting trace and then typing in -6 and hitting enter. And notice right there, you got y equals 0. That tells us, hey, that is a 0 of that polynomial, which means -6 will give us a remainder of 0 when we do synthetic division with it. But maybe I don't want to use -6. Maybe one of these others is a better, an easier one to do, right? -6, well, we probably know our 6 times tables. What's this one look like it might be? -1/2. Do we like dividing by fractions? No, I probably wouldn't use that one. But this one is 1, and I think 1